Making sense of your world with statistics. Welcome to this video, which will begin with a quick review of mean, median, and mode, and then discuss the 5-number summary. Statistics. We are constantly inundated with numbers everywhere, and making sense out of data is why statistics exists. Humans are overwhelmed by large streams of numbers, so condensing the numbers into a smaller descriptive list, even at the expense of losing some information, is desirable. Descriptive statistics are numbers that summarize data in some way. Let's start with a review of a familiar topic, a way to summarize data with a single number, the mean, median, or mode. Recall that given a list of numbers, the mean is the average of those numbers. That is, the sum of the values divided by the number of values. The median is the middle value when you order the list. And if there's an even number of values in the list, the median is the average of the two middle values. The mode is the most common number in the list. Note that a set of values may have more than one mode or no mode at all. Here's a quick example. Let's find the mean, median, and mode for this set of numbers. The first thing we want to do is to rearrange the numbers in increasing order. All right, so to find the mean, we want to sum each of these numbers in our list and divide by 8, which is the total number of values in our list. And we see the mean of this set is 20.875. For the median, since there are an even number of values in our list, the median will be the average of the two values in the middle. So 18 plus 21 divided by 2. The median is 19.5. The mode is the number that is found most common on our list. So this set of values has two modes, 18 and 24. Here's another example for you to try. If you're unfamiliar with mean, median, and mode, you may want to pause the video and try this one on your own before I reveal the answers. You'll first rearrange the numbers in increasing order. The mean for this set would be 76.57. The median would be the single number in the middle, 75. And the mode would also be 75, since it's the value most common on our list. One final example. The following list gives home prices in thousands of dollars for a small town. The list includes the price of one luxury home. Calculate the mean and median of this data set. Which of the two is more appropriate for describing the housing market? Here we go. For the mean, again, we add the values in our list and divide by the total number of values in our list, which in this case is 7, to see that the mean is 236.4. The median is our number in the middle, 140. Now, which of these two numbers, the mean or median, feels most appropriate for describing this set of numbers? Well, in this case, the median is more appropriate for describing the housing market, since 6 of the 7 houses on our list are less expensive than the mean. Now, the mean, median, and mode can provide helpful summary information about data, but a single value is limited in what it can convey and can even be misleading. For instance, consider the two data sets that appear below. What are the mean, median, and mode for each? Well, a quick computation will show you that for both sets of data, the mean, median, and mode are all 10. However, one way to visualize these two data sets would be like this. And in the visual, we see that these two data sets look very different, even though they have the same mean, median, and mode. So we need a different way in order to be able to tell the difference between these two sets of data. Additionally, we saw in example 3, the median gives us some information about housing prices, but it doesn't tell us anything about the spread of the data. It didn't reveal anything about that luxury home. Are most of the house prices clustered close to the median, or are they spread out over a wide range of prices? To help with these problems, One way to describe the spread of data is called the 5-number summary. So the 5-number summary consists of 5 numbers: the minimum value in our list, the median, called Q2, the maximum value in our list, as well as the first quartile or lower quartile Q1, which is the median of the lower half of the numbers in the list, and the third quartile or upper quartile Q3, which is the median of the upper half of the numbers in the list. Let's do an example. Let's calculate the 5-number summary for the data set we see here. So our 5-number summary consists of the minimum value on our list, in this example 5, the median value, which in this set would be the average of the 2 numbers in the middle, 10 plus 10 divided by 2, so 10, the maximum value on our list, 15, and now Q1, the median of the bottom half of the list, which would be 5, and Q3, the median of the upper half of the list, 15. So the 5-number summary for this data set would be 5, 5, 10, 15, 15. Here's another example for you to try. I encourage you to pause the video and calculate the 5-number summary for the data set 1, 2, 3, 4, 5, 6, 7, 8. So the minimum value is 1. The median would be 4.5. The maximum would be 8. Q1 is the median of the bottom half of the list, would be 2.5. And Q3, the median of the upper half of the list, would be 6.5. Before we move on, I want to do one more example to point out something strange that can happen with the 5-number summary if you have an odd number of values in your data set. So, as before, our minimum value is 1. This time we have a true median of 5 and a maximum value of 9. Now, when we go to compute Q1 and Q3, we need to be able to divide our data set into halves, a lower half and an upper half. What are we going to do with this median value of 5 that's stuck in the middle? Well, what we're going to do is we're going to ignore it from both sets. So, for Q1, the median of the bottom half will be the median of 1, 2, 3, and 4, so 2.5. And for Q3, the median of the upper half will be the median of the numbers 6, 7, 8, and 9, so 7.5. So our 5-number summary would be 1, 2.5, 5, 7.5, and 9. Here's one final example like this. Each year, Forbes magazine publishes a list it calls the Celebrity 100, which takes a stab at measuring the most ephemeral of riches, fame. The table below shows the top 9 names on the list for 2013, ordered according to the ranking of Forbes. Let's calculate the 5-number summary for this list of incomes. So here's our table again. We'll start by arranging the list in increasing order. The 5-number summary consists of the minimum value, 53, the median, of which we have a true middle at 77, the maximum value of 125. Now, keep in mind, when we go to compute the median of the lower half and upper half, we will exclude that true median of 77 from both lists. So, Q1, the median of the bottom half of the list, will be 56.5, and Q3, the median of the upper half of the list, will be 90. So the 5-number summary is 53, 56.5, 77, 90, and 125. Now, what is this telling us? What does the 5-number summary show? Well, it tells us that all of the incomes are between 53 and 125 million, between our minimum and our max. And because the median income is 77 million, it tells us as many incomes are above that level or as below. The lowest 1/4 of all incomes were between 53 and 56.5 million. The next 1/4 were between 56.5 and the median of 77 million. The next 1/4 are between the median of 77 and 90 million, and the highest 1/4 are between 90 and 125 million. So the summary provided by this breakdown gives us a general sense of how these incomes are spread out. And we can take this one step further with a visual. Here's a visual of our 5-number summary using something called a box plot. So the box plots include our minimum value, our first quartile, median and third quartile, our maximum, and any outliers if your data set has one of those. So how do we understand the 5-number summary? Well, it does a much better job of describing data than any single number could, just a mean, median, or mode. If the 5 numbers are relatively close together, the summary tells us that the data are fairly closely bunched around the median. If, in contrast, the 5 numbers are widely separated, we know that the data are spread out as well. In our next video, we'll look at another way to describe the spread of data, something called the standard deviation. I'll see you then. Thanks, guys.